In question number 5, the equation of a curve is xy plus y square e power minus x equals to 4. We have to show that dy dx is given like this. So in the first step, differentiate x and y, we have to apply the product. And the product will basically is bu dash plus uv dash to find dy dx. And if we take u is equals to x, so u dash would be 1. And if we take v is equals to y, the derivative of y with respect to x is y dash. We can write dy dx as well, but this is easier to write y dash. So we'll apply the this product rule on this first term over here. So this will become bu dash, that will be y times 1 plus uv dash, that is x into y dash, plus now differentiating the second term over here. So let's take u as y squared over there. U dash will become, so we'll apply the chain rule 2y, and the derivative of y will be y dash or dy dx. Doesn't matter what we take as u and v, by the way. So v in this case would now be e to the power minus x. The derivative would be, so we multiply the derivative of the power, which will be minus 1. So this will become like this. So again applying vu dash, we'll get 2 e power minus x, uh, and then we have y and y dash plus, but this is a minus sign, so we can just write minus uv dash will become y square e to the power of minus x equals to the derivative of 4 would be 0. Now to find dy dx, we'll separate these two terms. So we'll get x y dash plus 2 e power minus x y dash is equals to, taking this on the right hand side, this will become y square plus y square e power minus x, and this will become minus y. And now taking y dash common over here, so we'll get y dash is equals to x plus 2 e power minus x y is equals to y square e power minus x minus y. Now taking this on the right hand side, we get y dash is equals to y squared e power minus x minus y divided by x plus 2 e power minus x y. Now in this question, the powers of x are positive. So let's try and make them positive. We can write in the numerator as y squared into, or y squared upon e power positive x minus y. So that will be a numerator. And if we take the LCM over here, we'll get y squared minus y e power x divided by e power x. And similarly, let's try and simplify the denominator. This will be x plus 2y upon e power x. Taking the LCM, we'll get, and do we have x e power x? Yes, we have x e power x. So we'll get x e power x over here plus 2y upon e power x. Now we are dividing these two terms, so the numerator divided by the denominator. First, we can write it as y square minus y e power x divided by e power x divided by this term over here. And we know that when we bring the multiplication sign, these terms will flip. So we can now write it as multiplied by e power x upon x e power x plus 2y. So this and this will cancel out. And do we have the term now? Yes. So we have the final answer. That was y squared minus y e power of x divided by x e power of x plus 2y. So that was the first part where we had to prove the dy dx. Now in part B, it says find the gradients of the tangent to the curve when x is equals to 0. So we know that dy dx represents the gradient of the tangent. So we have the expression for dy by dx already, that is as given in the first part. Now we'll put x is equals to 0 over here. Now for x equals to 0, we also need to have a value of y to find the gradients. So from the equation over here, if we put x equals to 0 over here, this will become 0, and this will become e power 0 is 1. So we'll get y squared is equals to 4. So y squared is equals to 4. So the two values of y will get will be plus minus 2. So let's first put when x is 0, the two values of y are coming as 2 and minus 2. So let's put for 0 and positive 2. So this will be 2 squared minus 2 into e power 0 divided by. So this x is 0 plus 2 times 2. So this answer would become 4 minus 2, that is 2 upon 4. So this will become 1 upon 6. So one of the gradients will be 1 upon 2. And now taking x is equals to minus 2. So minus 2 whole squared is a plus 4. And then minus 2 into e to the power of 0 is 1 upon 0 plus 2 into. So that will become 2 into minus 2. And then 4 plus 2 is 6 upon minus 4. So the other gradient would come out as minus 3 upon 2.